If you've ever spent time walking around a major dirt project or a mining site, you've probably noticed something completely unique about modern Caterpillar bulldozers. Look at the undercarriage. Instead of the traditional flat, oval-shaped tracks, they have a massive, elevated sprocket sitting high up in the back, giving the tracks a highly distinct triangular shape. It's called a high drive system, and in the world of bulldozers, it is an absolute game changer for durability. But it raises a massive engineering question. If elevating the sprocket is such a brilliant, bulletproof piece of machinery design, why don't we ever see it on heavy excavators? To understand why, you have to look at the brutal physics of what these two machines are actually built to do. To truly grasp this, we have to go back to the late 1970s. The mining and heavy construction industries were pushing standard oval-track bulldozers to their absolute breaking point. When you take a 100,000-pound machine and repeatedly slam it into solid rock, something eventually gives. And back then, what usually gave was the final drive. The final drive is the heavy-duty gearing system that transfers power from the transmission to the tracks. On a traditional flat track, that vital, highly expensive component sits mere inches from the ground. It is completely submerged in mud, sand, and abrasive rock, absorbing every single bone-jarring shock of the earth. In 1977, Caterpillar decided to flip conventional wisdom completely upside down. They released the legendary D10 bulldozer, generating an astonishing 93 new patents in the process. The biggest innovation? They took that incredibly expensive final drive and pulled it up and out of the dirt. By elevating the sprocket, they isolated the most critical components of the drivetrain from the violent shock and impact of the ground. The track frame absorbed the beating, while the elevated sprocket floated safely above the carnage. For a machine that spends its entire existence smashing into the earth, the elevated sprocket was an absolute masterpiece of mechanical engineering. It increased the lifespan of the powertrain, provided better traction, and made it incredibly easy for mechanics to swap out a broken transmission right in the middle of a muddy job site without having to break the massive steel tracks apart. But an excavator is an entirely different beast. A bulldozer's entire life is based on violent, forward-pushing momentum. It exerts constant, relentless tractive effort. An excavator, on the other hand, is built for surgical precision. It is designed to dig, pivot, and swing thousands of pounds of heavy, wet dirt 30 feet in the air. Because of those vastly different operating dynamics, an excavator does not need to protect its travel motors from high-speed, forward-pushing impacts. Think about how an excavator actually works on a job site. It tracks forward a few feet, stops, and then spends the next 20 minutes sitting perfectly still while the hydraulic boom does all the heavy lifting. An excavator spends 90% of its working life acting as a stationary anchor. It doesn't push through the dirt with its tracks, it pulls through the dirt using the massive hydraulic breakout force of its bucket and stick. Because it sits still, what an excavator desperately needs more than anything else is gravity.
When you have a massive steel boom fully extended, ripping through deep, hard-packed clay at extreme angles, stability isn't just a nice feature, it is the only thing keeping that incredibly heavy machine from violently tipping over. When an excavator rotates its massive upper carriage, the entire weight distribution of the machine shifts drastically. If the operator swings a bucket full of wet mud over the side of the tracks, the laws of physics are actively trying to pull that machine into the trench. A traditional, low-drive, flat-track undercarriage provides exactly what an excavator needs to fight those forces, a significantly lower center of gravity. It maximizes the surface area of the steel tracks, ensuring a rock-solid, incredibly consistent footprint on the ground. You want the heavy metal weight as close to the earth as mathematically possible. If you were to take an elevated, triangular high drive system and bolt it onto an excavator, you would completely ruin the geometry of the machine. By raising the track frame and pushing the heavy drive components higher up into the air, you would make the excavator dangerously top-heavy. It might look incredibly tough, but the moment you swung a heavy concrete pipe over the side of the tracks, the machine would lose its balance and tip over. In the dirt world, a top-heavy excavator is a deadly excavator. Then, you have to look at the harsh realities of undercarriage wear and tear. On a bulldozer, the steel tracks are constantly moving. A dozer might travel several miles a day, grinding back and forth across highly abrasive terrain. The high drive system is brilliant for dozers because it drastically reduces the internal bushing wear when the machine is backing up. But an excavator rarely travels long distances. The wear and tear on an excavator's undercarriage doesn't come from driving miles down a rocky road. It comes from the machine rocking back and forth on its track rollers while digging heavy loads. Because the wear mechanisms are fundamentally different, adding a high drive system to an excavator wouldn't solve any actual problems. In fact, it would just create new ones. Elevating the sprocket requires an additional idler wheel to create that triangular shape. In mechanical engineering, adding more moving parts means adding more points of failure, which reduces overall track life for a machine that doesn't benefit from the design in the first place. Finally, there is the simple, unavoidable reality of economics. Elevated sprockets are incredibly complex, highly specialized, and deeply expensive to manufacture and maintain. The travel motors on a modern excavator are relatively simple hydrostatic units that are already tucked safely inside the heavy steel of the track frame. They are heavily protected from debris, incredibly reliable, and relatively inexpensive to maintain. Because the standard low-drive undercarriage is already perfectly optimized for the stationary digging motions of an excavator, there is absolutely zero economic or practical incentive for a manufacturer to overcomplicate it. In the high-stakes world of heavy iron, form always follows function. You don't build a hammer to do the job of a scalpel, and you don't engineer a track system to solve a problem that doesn't exist. The elevated high-drive sprocket was designed to conquer the brutal, forward-smashing reality of heavy rock dozing, and it remains the undisputed king of rough terrain pushing. But when it comes to extreme lifting, precision digging, and keeping a massive swinging machine safely anchored to the dirt, the traditional, low-slung, flat track is still the undisputed champion of the job site.